This question is a question based on straight line graphs. This is a very important topic. And also, if you check the prediction video that I made for paper 2, there I have mentioned a very important question that is about finding the equation of a perpendicular line that is a bisector. Please make sure you go through that because that is highly expected. So please make sure you go through that. And before we work on this, the questions that we have here, let's quickly go through the formulas that you need to remember that is related to this topic. When it comes to a straight line graph is of the form y is equal to mx plus c, where the c is called as the y-intercept and m is the gradient. Now, the y-intercept is the place where the graph hits the y-axis, for example. Now, if I just draw a small sketch here, now this is the x-axis, this is the y-axis, and let's say that I'm going to draw a line like this. This is the place where this line, the graph that I have drawn here, hits the y-axis. So that is called as the y-intercept. Next is m. M is the gradient, so the gradient measures the steepness of a graph. Now, when you have a line that goes down like this, we say that the gradient is negative because this is a decreasing graph. So for a decreasing graph, the gradient is negative. If the graph is increasing, which will be in this direction, then we say that the gradient is going to be positive. Now, when calculating the gradient, we have two formulas. One is to use rise over run. Rise explains how many units you need to move up or down, and run explains how many units you need to move across. Or else we can use the formula y2 minus y1 over x2 minus x1. Now, for distance, midpoint, and gradient, these three formulas that we have here are very important, because these three formulas are used to calculate the gradient, distance, and midpoint when two coordinate points are given to us. So then we will discuss questions related to this. And then the next thing that is very important about this topic is about finding the equation of parallel and perpendicular lines. Now, when a line is already given to you, or when a line's equation is already given to you, if you are supposed to draw a line that is, if you are supposed to find the equation of a line that is parallel to that line that is already given, in that case, we need to understand that the gradient of the parallel line will be the same gradient as the gradient that is given, as the gradient of the equation that is given to us. When it comes to a perpendicular line, the gradient of the perpendicular line will be the negative reciprocal of the gradient of the equation that is given to us. For example, now if we say that y is equal to 2 over 3x minus 2 is the equation of the straight line that is given to us, if I'm to find the equation of a parallel line, then the y-intercept will be different, but then the gradient will be the same. So it will be y is equal to 2 over 3x, and then the y-intercept will be different. So this is for a parallel line. But when it comes to a perpendicular line, if I'm to find an equation that is, if I'm to find an equation of a line that is perpendicular to this line that is given here, in that case, the gradient will be the negative reciprocal. Negative reciprocal means that you need to flip the fraction and change its sign. So that means when I flip this fraction 2/3, it becomes 3 over 2. And then the sign for this 2/3 is positive, which means I need to put the negative here because I need to change the sign and write it. So I will have negative 3 over 2x, and then I will have the y-intercept. In this case, for the perpendicular line, the y-intercept will completely depend on what point they have mentioned in the question. So in that they will usually give you a coordinate point for that. So we will have to substitute that to find the y-intercept. Now, if the value of this gradient is given to us as a negative value, then to find the perpendicular line's equation, the gradient will be positive because we simply switch the sign. Negative reciprocal doesn't mean that the gradient of the perpendicular line is always negative. That's incorrect. It can be negative or positive. That depends on how the equation is given. Whatever the equation's gradient is, you simply change the sign, flip the fraction, flip whatever the number, whole number or the fraction that you have, and change its sign. That is how the gradient of the perpendicular line is calculated. So then let's move on to the question. In this question, P has coordinates -1, 3 and Q has coordinates 6 and 4. Find the coordinates of the midpoint of PQ. To find the coordinates of the midpoint of PQ, so we need to use the midpoint formula. So that is, we add the two x values divided by 2, we add the y values and divide it by 2. So it's like we're trying to calculate the average of the x values and the average of the y values. So I'm going to label the coordinates here as x1, y1, and then this coordinate, I'm going to label it as x2, y2. Now I'm going to substitute the values here. x1 is -1 plus 6 divided by 2. y1 is 3. y2 is 4 divided by 2. So -1 plus 6 is 5. 5 divided by 2 is 2.5. And then 3 plus 4 is 7. 7 divided by 2 is 3.5. So this will be the coordinates of the midpoint PQ, midpoint of the line PQ. Then the next one is to calculate the length of PQ. So in this case, you will have to make use of the distance formula. So it's very important that we remember the formula for midpoint, distance, as well as a gradient. So here we need to use the distance formula, which is similar to the Pythagoras theorem. It's like trying to calculate the hypotenuse using the Pythagoras theorem. So we square the, we find the difference between the x values, square that, add that with the difference of the y values, square that, and the answer that we get here has to be square rooted. This will give us the length of PQ. So this is going to give us the hypotenuse or the length of the line that they have mentioned in the question. So here we need to find what PQ's length is. So now I'm going to substitute the value of x1, x2, y1, and y2 into this equation. So that is x2 is equal to 6. So I have 6 minus 1. And then I have the square plus y2 is equal to 4. 4 minus 3 with the square. I need to square them, add them together, and then I need to square root it, or directly I can put this in the calculator and see what I get as the answer. So I'm going to put this in the calculator. So I have 6 minus 1. So 6 minus 1 is the same as 6 plus 1 with the square. And then I have plus within the brackets, I have 4 minus 3 with the square. So then, and then I have put the square root as well. So this gives me the answer 7.07 correct to 2 decimal places, which means the length of the line PQ is equal to 7.07. The next question is to calculate the gradient of PQ. To find the gradient of the PQ, PQ, we need to use the formula, the gradient formula, which is y2 minus y1 over x2 minus x1. So now this is used to calculate the gradient of the line PQ for the two coordinate points given here. Now we need to substitute it here. y2 is equal to 4 minus y1. So y1 is -1. So it's going to be 4 minus -1 over x2 is equal to 6. I need to subtract x1. x1 is, okay, so here previously, okay, hold on, made a mistake here. So it should be 4 minus 3 over x2 is 6, 6 minus -1. This is how it should be. So 4 minus 3 is a 1. 6 minus -1 is 6 plus 1, which is the same as a 7, which means the gradient of the line PQ is 1 over 7. This is what we get. Then the next one that we have is to find the equation of a line of the line PQ that crosses the x-axis at x is equal to 2. And this line PQ should be a parallel line. You need to find the equation of the line that is parallel to PQ and crosses the x-axis at 2. Now, when we see the term parallel, we did discuss that if a line is parallel to a line that is given to you, then the gradient will be the same, which means the first part of the equation will be y is equal to 1 over 7x, because the gradient will be the same 1 over 7 as this PQ. So then, now we know y is equal to 1 over 7x plus c. I need to find what the c is. C is the y-intercept. We need to know the y-intercept to write this equation, the equation of the line that is parallel to this PQ. Now, To find the value of C, I need a coordinate point to substitute for x and y, only then I can find what C is. Here indirectly they have mentioned what coordinate point to use. In the question, it clearly states that the line that is parallel crosses the x-axis at x is equal to 2, which means if I'm to briefly sketch this diagram here, now we know that here the gradient is positive, it's going to go up like this, and it's going to go through 2 in the x-axis this way, which means now in this case, this is that point that they have mentioned here, so it crosses the x-axis at x is equal to 2. Now we need to find what this y-intercept is. To calculate this y-intercept, we can think about the coordinate point of this 2. So here the value of x is 2, the y value is 0. That means this is that coordinate point that has to be substituted into this half-completed equation to find the value of the y-intercept. So then I can write it as 0 is equal to 1 over 7 times 2 plus c. So 1 over 7 times 2 is the same as 2 over 7 plus c. I'm going to take this 2/7 to the other side, that becomes negative, which means the value of c is equal to negative 2 over 7. This becomes the next part of the, this combines with this first part of this equation that we have written, which is minus 2 over 7, because that is the y-intercept through which the parallel line crosses or passes through. Let's move on to the next question that we have. Also, there's another thing that I wanted to mention. I'm not sure if I mentioned it already, but please make sure to have a look at the prediction video that I made for paper 2. In paper 2, I know that like in paper 2, if you check the questions that I have selected, there are certain questions that are highly expected. So even though it did not appear in paper 2, there are very high chances that it could appear in paper 4. And in paper 2, there's this question that I have explained, which is about finding the equation of a perpendicular bisector. That is very important. So please make sure to go through that. Let's move on to the next term that we have, which is related to inequalities. Now, let's see in inequalities what we have to know before we work out this question. There isn't much in inequalities, but when it comes to equations or inequalities, in expressions or equations that are there with different inequality signs, keep in mind that whenever we multiply by a negative number or divide by a negative number, that is when the inequality sign changes. Then when graphing inequalities, when we have a line under this symbol like I have shown here, that is greater than or equal to or less than or equal to sign, that is when we have to draw solid lines to graph it. And the solid line actually means that any point on the line is also a solution. And when we consider these inequality signs here, so that is greater than and less than sign, that is the ones without the line under. In that case, we will have to draw the straight line using a dashed line like this. And the dashed line actually means that any point on that line is not a solution. That's the meaning. Now, when we graph inequalities, there will be instances when you will be given more than 2 inequalities and we will have to graph it, shade it, and identify the region that represents the 3 inequalities. In that case, it's important that we shade in the region that does not belong to it, and then we will easily be able to identify which one is going to be the solution for the 3 inequalities, or the solution that satisfies all 3 inequalities. That will be the unshaded region, because we are trying to shade the region that is not wanted. Now let's try working out this question that is given here. So in this question, find all the positive integers which satisfy the inequality 3n minus 8 greater than 5n minus 15. So in this case, to solve this, we got to solve it just like solving equations. The only difference is that we do not have an equal sign. Instead, we have a greater than sign. So now we are going to bring the 5n to this side, and I'm going to take this minus 8 to the other side. So that becomes 3n. The 5n, when I take it to the other side, that becomes minus 5n. and I have this greater than symbol. The minus 8, I'm going to take it to the other side. In the other side, I already have minus 15. And when I take the minus 8 to the other side, that becomes plus 8. So from 3n, when I deduct minus 5n, I end up getting minus 2n. This is greater than minus 15 plus 8. When I solve that, I get negative 7. I need to find what n is. So I got to divide this by negative 2, which means this negative 2n has to be divided by negative 2. The same way, I need to divide this negative 7 also by a negative 2. The reason why I divide by a negative 2 is to get rid of the negative 2 that I have in front of this n. The moment I divide it by a negative number, I know that the inequality sign will flip, which means it will turn the other way around. So then, when I divide negative 7 by negative 2, I get the value of n as a positive value. The value of n is less than 3.5. And in the question, it clearly states that to select all the positive integers that satisfy this inequality, which means all positive numbers, positive whole numbers that are less than 3.5 has to be considered, which means it can be 3, then it can be 2, or it can be 1. So those are the only positive integers that we have, which are less than 3.5. Let's move on to the next part of the question that is given. Now here already, the region that satisfies all three inequalities is given to us, which is this region R, because this is the region that satisfies all three inequalities. And here, the unwanted regions are the ones that are shaded. And that way, the wanted region, the region that satisfies the three inequalities, will be the unshaded region. Now, in this question, it states that the region marked R is defined by three inequalities, which means it satisfies all three inequalities. We need to write the equation of these three inequalities. Now, the equation of these three lines, the straight lines, are given to us. So we have x is equal to 4. Then we have this one, which is 10y plus 8x is equal to 80. And we have 2y is equal to x minus 4. The equations are given to us. But we are supposed to write the inequalities. So like I mentioned already, the unwanted region is the one that is shaded, which means now when we consider this x is equal to 4 line, the region that is to the left side of this is shaded, which means that is the unwanted region. That means the actually wanted region will be the region that includes this R, which means that's going to be x is greater than 4. Only then this section that belongs to this R will be included. The next one is we have 2y is equal to x minus 4. The region that is shaded is below this line. The region that we are actually, the wanted region is the region above this, because that is the region where R is included, which means we need to write this inequality and everything above this should be shaded. So that's going to be 2y is greater than x minus 4. This is going to be the next inequality that we have. And then the next one, the last one that we have is this line here. Now, when we consider this line, the region that is shaded is going to be the region above. That is the unwanted region. So the wanted region will be the region that is not shaded for it. That is the one that is below this, that includes this R, which means I would write the same inequality, which is 10y plus 8x. But then this time it's going to be less than 10, less than 80, because that is this number that we have. But then now if you check the, if you have a look at the ways how the lines are given to us, the first two equations that we wrote, they are dashed lines or dotted lines. In that case, we wouldn't put a line under. But when we consider the last inequality that we wrote, it is a solid line, which means that any point on that line will also be considered as a solution. Therefore, I need to make sure to write this inequality sign with a line under. So this is how it should be written. Now, the next part of the question is where write down the largest value of 3x plus y in the region for x, for the integers x and y. It clearly states that x and y are integers, which means they are whole numbers. The region that is in R that gives the largest possible value is what we are supposed to find. So then the values that give you that give you whole number integers as solution, that is in this region R, is going to be this point, these 4 points, then we can pick these 2 points, and I can pick this point, because all the other points that we have here are will not give you whole numbers. At the same time, we should also understand that anything on the dotted line or the dashed line will not be considered as a solution. So out of these points, we need to see which one gives us the largest possible value. So if I pick this point here, the value of x is 5, the value of y is 4, which means it's going to be 3 times 5 plus 4. So that will be 15 plus 4, that is equal to 19. Then the next one that we have is, okay, so the same way, if I try to check 6 and 3, so the value of x is 6, the value of y is 3, that means it's going to be 3 times 6 plus 3, 3 times 6 plus 3, so that is the same as 18 plus 3, so that's going to be 21. But still, we haven't figured out the largest possible value, so that's going to be this 7, 2. So when we do that, it's going to be 7 times 3 times 7, so it's going to be 3 times 7 plus the value of y, because it states that it's 3x plus y. So for this 7, the value of y is 2, which means 3 times 7 is 21, 21 and 2 is going to be 23. This is the one that gives us the largest possible value. And we are supposed to write the largest value of 3x plus y, that is equal to this 23. This is how we will be doing it. With that, we will be done with the questions related to inequalities. Let's see what we have next. This is the next question that we're going to discuss, which is about which is a question that is related to volume, surface area, and I have also picked a question related to area of sectors. So then let's work on this question that we have here. So before we do this question, we will go through the important concept that you need to know when it comes to surface area, volume, and area. These are the formulas that we need to know when it comes to area. It's very important that we know all these formulas. So when it comes to a trapezium, so we need to add the parallel sides together. So this is that side A plus B should be added, divided by 2, and we need to multiply it with the perpendicular height. This perpendicular height is the distance between the parallel sides, whereas this A and B are the parallel sides. When it comes to a rhombus and a kite, they both have the same formula, which is the product of the diagonals. We multiply the 2 diagonals together and divide it by 2. Area of a circle is pi r squared. And to calculate the circumference is like the perimeter of the circle. So to find that, we need to do 2 pi r, or we will have to do pi d. The next one is to calculate the area of a sector. We write the angle out of 360 times pi r squared, because a sector is a fraction of a circle. So we write that fraction here out of 360, the angle out of 360, and then times it with the area of the circle formula. Then when it comes to the perimeter, when we have a sector, we have 3 sides, that is the 2 radius or the 2 radii, and then we have the arc length. To calculate the arc length, we do angle out of 360 times it by 2 pi r. With that, we need to add 2r. So this gives us the perimeter of the sector. If we are just asked to find only the arc length, then in that case, we wouldn't be adding this 2r to it. So these formulas are very important to keep in mind. The next set of formulas that are very important for us to keep in mind is the formula for the surface area and volume of cylinders. Now, when it comes to cylinders, this formula will not be given to us. It's very important that we keep this in mind. And then when it comes to the surface area of a cylinder has 3 sides, that is, it has 2 circles and a curved surface. This curved surface is this rectangular portion that we have when we cut that open. So in that case, to calculate the surface area, we multiply the area of the circle by 2 and then add that with the curved surface that we have. Sometimes there will be instances where the cylinder that is given to you will not have a top to it, or it will not have a bottom to it. That means now if we consider a container without a lid, in that case, you will have only one base. So there we will have to modify this equation, the surface area equation, and write it as just pi r squared plus 2 pi r h. The same way, if there is no top or no bottom, just like a pipe, in that case, we will have only the curved surface of the cylinder. There, we will just use the surface area formula as 2 pi RH because we will not have both the circles, so we will not write this part. When calculating the volume of a cylinder, we multiply the area of the cross-section with the height if it has a cross-section. So then, in this case, the cross-section is the base, which is the circle. So we calculate the area of the circle by using the formula pi r squared, and we multiply it with the height. Height is the side along which the cross-section stays the same. Now, the same way, if we are to calculate the surface area and volume of a sphere, this will be given to us, the surface area and the volume of a sphere. But then, the surface area and the volume of a hemisphere will not be given. When it comes to a hemisphere, the volume of the hemisphere will be half the sphere's volume. So we have 4/3 pi r cube here. So when we halve that, we get 2/3 pi r cube. Then when it comes to the surface area, this is something somewhat tricky. That is, if the solid that if the shape that is given to you is a solid hemisphere, in that case, we would go with the formula 2 pi r squared plus pi r squared, because this 2 pi r squared is half of the sphere, because this is a hemisphere. And then we need to add another pi r squared to it because this top surface is also there, because this is a solid hemisphere. So due to that reason, the surface area of a solid hemisphere will be 3 pi r squared. But the same hemisphere, but if this hemisphere is a hollow hemisphere, which means it will not have this top. Therefore, in that case, when you calculate the surface area of the hemisphere, we just divide the surface area of the sphere into 2 and write it as 2 pi r squared, because it does not have this top circular portion. It just has only one curved surface, which is found by using this 2 pi r squared. And in addition to this, we have pyramids, and then we have rectangular prisms, cubes, and things like that. But those formulas, cubes, rectangular prisms, we will be able to understand it easily. And when it comes to pyramids, cones, the formula will be given to us. So based on how the formula is given, we can work that out. But here, these formulas are very important to keep in mind. Next, we have to have an idea about how the unit conversions take place. When it comes to length or perimeter, so the conversion has a pattern here. It goes as kilometers, meters, centimeters, millimeters. So whenever a larger unit is converted to a smaller unit, you should always multiply. So we need to multiply here when converting the larger unit towards the smaller unit. And also there is a pattern. It goes as 1,000, 100, and then 10. When it comes to surface area, it's going to be the same thing, but then the difference is that as the units have a square here, the amount that is used to convert also has to be squared. When it comes to volume, the units get cubed. The same way, the amount that is used to convert also has to be cubed. Then if we are to do it the other way around, that means to convert a smaller unit into a larger unit, then in that case, we will have to divide it by the same amount that is mentioned. And then that way we will have to convert a smaller unit into a larger unit, we will have to do division. Then when it comes to capacity is how much something can hold. Now, when it comes to, that is the measure of liquids. So we usually measure that in milliliters, liters, kiloliters, megaliters. And here the conversion is multiplying by 1,000 each time. From a larger unit to a smaller unit, we need to always multiply, and here it's multiplied by 1,000 always. And then when it goes the other way around, it's going to be divided by 1,000. Now, this one, which is about volume and capacity, is very important because now when we consider the units of volume and capacity, cubic centimeters and milliliters, they have a relationship. These two are equal to each other. The same way, cubic meters and kiloliters are also equal, which means, for example, if I say that there is a tank which has a volume of 1 cubic meter, and if we are to check how many liters of water the tank can hold, I can clearly say that 1 cubic meter tank can hold 1 kiloliter of liquid or water. But if I'm supposed to find it in liters, then after converting it into kiloliters, then I need to convert it into liters by timesing it by 1,000. So I can do it that way. So then this is why to convert a unit that is in volume, to convert it into capacity, we need to know these two relationships. That's why this is very important. When it comes to mass, they are multiplied by the same 1,000 each time or divided by the same 1,000 each time. And when we have time, there is a pattern. So it goes as 24, 60, 60. So this is how it works. So this chart is very, very important. An empty fuel tank is filled using a cylindrical pipe with diameter 8 centimeters. Fuel flows along this pipe at a rate of 2 meters per second. It takes 24 minutes to fill the tank, and we need to calculate the capacity of the tank and to write the answer in liters. Now, there is a pipe that fills the tank. So this pipe is going to fill a tank like this with water. Oh, I'm sorry, with fuel. So in this case, the diameter of this pipe is given to us. The cylindrical pipe's diameter is given as 8 centimeters, which means the cylindrical pipe's radius is equal to 4 centimeters. Then the next one is, it states that fuel flows along the pipe at a rate of 2 meters per second. This 2 meters per second states that in 1 second, 2 meter, now when if there is a pipe that is 2 meter long, if the same pipe is 2 meter long, the fuel that 2 meter long pipe can hold is filled into this tank. That's the meaning. That means in 1 second, if it can fill 2 meters, they are asking 2 meters, then they are asking if it takes 24 minutes to fill the tank, we need to calculate the capacity of the tank, which means in 1 second it fills 2 meters. Then in 24 minutes, we first need to find what length will it be that should be filled with fuel for it to fill the tank here. So 24 minutes is the same as to convert it into seconds, and it times this by a 60. So when I times this 24 by a 60, that gives me 1,440 seconds, which means I need to find what amount, what length of fuel that fills into this cylindrical pipe is filling the tank that is given here, which means to calculate that if in 1 second, if it is 2 meters, then to find for 1,440 seconds, I need to times this 1,440 by 2. When I double that, I end up getting 2,880 meters. It means that a 2,880 meter long pipe that has a radius of 4 centimeters filled with fuel is filled into this tank. That's the meaning. That means now I can calculate the volume of this cylindrical pipe that is 2,880 meters long, because to calculate the volume of a cylinder, we use the formula pi r squared h. Pi times the radius of the cylinder is going to be 4 centimeters. So I'm going to write it in meters because the length is given here in meters. So this 4 centimeters in meters is the same as 0.04 meters, because I need to divide the centimeters that I have here by 100 to convert it into meters. So that is what I did here. So this is 0.04. I need to square this and times it with the height. This height is the length that is mentioned here, which is 2,880 meters. I'm gonna multiply this. So when I multiply this, I get the answer in cubic meters. So then let me put this in the calculator. So I have pi times, then we have 0.04. I need to square that because it's pi r squared times the length, which is 2880. So when I do that, this is what I get as the answer. But this answer that I get here is the answer in cubic meters. Now, previously we discussed that there is a relationship between cubic meters and kiloliters, that is, they both are equal, which means the answer that I get here should be converted to, is going to be in kiloliters, can be converted to kiloliters. Then again, if I'm to convert it into liters, then I will have to times it by 1,000. That's what we are supposed to do, which means this answer that I got here is 14.476. So I'll write it as 14.476. And let me also add another 2 decimal places as 458. I'll write it as 46. So this is going to be the amount in cubic meters. This is the same amount in kiloliters as well. And then I need to convert it into liters. So I need to times this by 1,000. When I times this by 1,000, the decimal point moves 3 steps to the right, which leaves me with 14,476.46 liters. So this is the amount of fuel that this tank can hold, which is what we are supposed to find. This is a very important question because there can be instances when they could give you cylinders involving this rate of flow. Let's move on to the next question that we have. The diagram shows a solid cone and a solid hemisphere. This is very important. The solid cone, the term solid is very important, and a solid hemisphere. The radius of the cone and the slant height is known. The hemisphere's radius is not known, that is marked as r, but it states that the total surface area of the cone is equal to the total surface area of the hemisphere. So I can write it as total surface area of the cone is equal to the total surface area of the hemisphere. Now the question is for us to calculate what r is. The formula to calculate the curved surface area is given to us as pi rl, and to calculate the curved surface area of a sphere is given to us as 4 pi r squared. That means when it comes to a solid cone, we have two surfaces. One is the curved surface, and then we have the base, which is the circle, which means the formula to calculate the total surface area of a cone will be pi r squared plus pi rl. The same way, if we are to calculate the total surface area of a solid hemisphere, it has this curved surface, which is half of the surface area of a sphere. So it's going to be 4 pi r squared divided by 2. That's going to be 2 pi r squared. With that curved surface, I should add this area as well. That is the area of the top that we have, which is pi r squared. Which means now I can write this one as 3 pi r squared as well. So this 3 pi r squared, so in this case, the radius of the hemisphere is given as r. So I can write it as 3 pi r squared here. That is what we are supposed to find, is equal to this pi r squared plus pi rl. I'm going to substitute the values given in the question to find the answer. So then pi times the radius is given to us as the radius of the cone is given to us as 2.4. So that's going to be 2.4 squared plus pi times the radius is 2.4 times the length is 6.3. So then let's put that 6.3 here times 6.3. This is what we have. In the other side, we have 3 times pi times r squared. This r is what we are supposed to find. So we're going to make r the subject. I'm going to take this 3 pi entirely to the other side. So it divides everything that we have here. So then this 3 pi will divide everything that we have here. So I'm going to put that 3 pi. So then the 3 pi's gets cancelled out. That is equal to r squared. So if I'm to find what r is, the answer that I get here has to be square rooted. Only then I can find the value of r, because the square root and the square gets cancelled out, so leaving us with the value for r. I'm going to put this in the calculator and see what we get as the value. So we have the square root fraction, then we have pi times 2.4 squared plus we have pi times 2.4 times 6.3. Then in the denominator we have 3 times the value of pi. So when we solve this, we end up getting the value of r as 2.638. So correct to 2 decimal places, it will be 2.64. So 2.64 centimeters is the radius of this solid hemisphere that we have, that we are supposed to find. With that, we are done with this question. Let's move on to the next one that we have, which is this one. That is to calculate the area of the shaded region that is given to us. In this question that we have here, the diagram that is given to us is a rhombus. A rhombus is a slanted square, which means all 4 sides in that rhombus is equal to each other. So if this is 13.6, this side will be 13.6, this side is 13.6, and this side will also be that same 13.6. And just like in a parallelogram, the opposite angles are equal, which means if this is 41, this angle that we have here will also be 41 degrees. Now, in the question that is given to us, we are supposed to calculate the area of the shaded region. Now, to calculate the area of this shaded region, first I'm gonna split this into 2 like this. So I'm gonna draw a line in the middle like this. So let me draw a line in the middle like this. So this is the line that I'm gonna draw. And what I'm gonna do is I'm gonna draw the sectors separately. So that is, I'm gonna draw this sector and I have another sector as well. So I'm gonna draw any one of the sectors separately. So then let's draw that sector. So I'm gonna draw it here. So this is one of the most important questions that we need to know, because there are instances where like question like this are repeating. So please make sure you go through this once again. So when we consider the sector that we have, this is how the sector is. From the area of the segment, now from the area of the sector, I'm gonna deduct the area of the triangle. That is, now this is a sector that is given to us. I'm gonna deduct the area of this triangle. When I deduct the area of this triangle, I am left with this portion here. This is actually a part of a circle. We call this portion as the segment. So this way I can calculate how much this segment is. Then what I'm going to do is I'm going to calculate the area of the sector. So this is going to be sector means I know the formula is angle out of 360 times pi r squared. So I'm going to use that to calculate the area of the sector. So then let's write it. So it's going to be 41 over 360 times pi times the radius square, which is 13.6 square. This is going to be the radius. So this will give you the area of the sector. From this area of the sector, I need to deduct the area of the triangle. In this case, the included angle for the triangle is given, which means we are going to make use of the formula half AB sine C to calculate the area of the triangle. So that's going to be half times A is 13.6. I need to square that because 13.6 times 13.6 is what I'm going to do. And then I need to multiply it with the sine angle of 41 degrees, sine of this 41 degree angle. So I'm going to put this in the calculator and solve it. So when I try solving this, this will give us the area of the segment. So then let's put this in the calculator and see what we get as the answer. So then we have to calculate, okay, first let me put the brackets, fraction. We have 41 over 360 and I need to times this with 5 times the radius square, which is 13.6 square. I'm going to close the bracket. From this, I need to deduct the area of the triangle, which is going to be half times AB sine C. So that is half times A is 13.6. I need to square that times sine of the angle, which is 41 degrees. So this is what we have. So that is equal to 5.50496. This is equal to the area of one of this segment. So that is, if I'm to shade in, this is going to be the segment's area. Now what I'm going to do is, I'm going to double this amount. When I double this amount, I get the area of two sectors. So I can write it as 5.5049. This is going to be the, okay, 496. So this is going to be the area of one of the segment. I need to find the area of two segments. So to calculate, or else what I can do is, I can just leave it like this itself. This is the area of the segment that we have here. Now what I'm going to do is, from the area of the triangle, I'm going to deduct the segment. So that will give us one side of the one portion that is shaded. That means I can write it as, to find the area of the shaded region, from the area of the triangle, I can deduct the area of the segment that we just found. The area of the triangle is again half times AB sine C. So I can write it as half times A is 13.6 squared times sine C. That's going to be sine 41. From this, I need to deduct the area of the segment. This segment that we have here is calculated already, which is 5.50496. That is the area of the segment that we have. So from the area of this triangle, when I deduct this, I end up getting this portion as the area. This is going to be the area of one of the triangle, one of this portion. I have two identical portions, which means once when I do this, I need to times this answer that I get here by a 2, because I have two such regions. So that's the reason why I need to times this by a 2. So this will give us the area of the shaded region, which means I'm going to put this in the calculator now. From the area of the triangle, so that's going to be, I'm going to put the brackets and start. So area of the triangle, so that's going to be half times AB, that's going to be 13.6 squared, A times B times sine C. So sine C is equal to sine 41. So when we calculate this, this is what we get. From this area, from that area of the triangle, I need to deduct this 5.496 that we got previously. And once when I do that, I need to double this answer that I get by 2. So when I double this, I need to double it. Double it means multiplying by 2. So when I do that, I get 110.33. So that 110.33, and this will be in centimeters squared, will be the area of the shaded region. So this is how we need to do. So here we should also understand that there are instances when this segment and this segment will not be identical. There will be a difference. It will completely depend on what angle we have. So then, but anyways, this is how we should do to calculate the area of the shaded region. Let's move on to the next question then. The next question is a question related to probability, which is very highly expected as well. And there is a very important part in probability that we need to know. That is to answer the last part here that we have here. This is very important. So we might get something like this as well in the probability question in paper 4. So then let's see how we can do this question. So it states that Lucia has two fair spinners. Spinner A is 5-sided and numbered from 1 to 5. And spinner B is 9-sided and numbered as 3, 3, 3. Then we have 4 4s and 2 5s. Now, in this question, it states that Lucia spins the 2 spinners and records whether they land on a prime number or not. Now, in spinner A, the prime numbers that we have are 2, 3, and 5. So then the probability of getting a prime number is 3 out of 5. That means not a prime number means there are 2 numbers out of those 5. So we would write it as 2 out of 5. The next one is for spinner B, getting a prime number, we need to check. The numbers that are prime are 3s. So we have 3 3s. And then we have 5s. So that's going to be 5 out of 9. Which means getting a prime number is going to be 5 out of 9. And not a prime number will be the 4 4s that we have. So that's going to be 4 out of 9. I'm going to do the same thing here. I'm going to repeat the same thing that we wrote here. So that is 5 over 9. And then we have 4 over 9. This is what we have. Then the next part of the question after completing the tree diagram is find the probability that the 2 numbers are both prime. Both the numbers are prime, which means the first one is also prime. The second spinner also ends up giving us a prime number, which means simply the 2 probabilities that are on those 2 branches has to be multiplied together, because this is the only way you can get prime and prime. So you need to multiply these 2 probabilities together. So that's going to be 3 over 5 times 5 over 9. So then when we do this, I can simplify it here by crossing out the 5 and the 5 because they both are divisible by 5. And I can also cross out the 3 and the 9 here by dividing both by a 3. So that becomes a 1 and a 3, which means here the probability is equal to 1/3. So this is what we get here. The next question is, find the probability that the 2 numbers are not both prime. Not both prime means, now in this case, getting both prime is going to be 1 out of 3. Not both prime means it's going to be the opposite of this 1 over 3. That means now I need to, from a whole number 1, I need to deduct 1 over 3, which is equal to 2 over 3. This is what I get as the answer. So in this case, again, not both prime means that, now not both prime means not prime and not prime. Apart from that, the others. Even then, now not both prime means apart from P and P, everything else, these 3. Which means I can even find the probability of these by multiplying 3/5 with 4/9, 2/5 with 5/9, then 2/5 with 4/9. I can multiply them, find their probabilities and add them together. Still, it will give us the same answer, 2/3. Then let's move on to the next one that we have. Lucia spins spinner A 120 times. Find the expected number of times the spinner lands on a prime number. Now, for spinner A, for it to land on a prime number, for spinner A, landing on a prime number is the probability was 3 over 5. So then that probability should be times with the number of trials, which is 120. This gives us the expected number of times the spinner lands on a prime number. So then in this case, I need to times 3/5 and 120 together. So when I multiply 3/5 and 120 together, it gives us 72, which means the spinner lands on a prime number 72 times. Let's move on to the next one that we have. Lucia spins spinner B twice. Find the probability that the 2 numbers it lands on add up to 9 or more. So then I'm going to explain this question in 2 methods. One is using a small grid like this. And then I will also explain how to do this question without a grid as well. So first, let me explain it without a grid. So then the two numbers should make a total of 9, and it's going to be the same spinner that is spun twice. So that's going to be spinner B. So in this case, it should be getting the possible ways in which we can get a 9 or more. The numbers that we have in spinner B is that we have 3, 4, and 5. The possible combination in which we could get a 9 is we can get a 4 in the first time. When we spin the spinner for the first time, we can get a 4, and then we can get a 5, then getting a 5 in the first instance, and then getting a 4, or both being a 5. So these are the possible combinations in which we can get a total of 9 or more than 9. Now, the probability of getting a 4 when we spin the spinner is going to be 4 out of 9 chances. So the probability is 4 over 9. The probability of getting a 5 is 2 out of 9. So I need to times these two together. This gives us 8 out of 81. Then getting a 5 is 2 out of 9. I need to times it with getting a 4. The probability is 4 over 9. When I multiply this, this also gives us 8 over 81. Both being a 5 is, getting a 5 is 2 out of 9. I need to times it with, again, getting a 9. That's going to be 2 out of 9. This is the same as 4 out of 81. Now what I got to do is, I need to add these three together to calculate the total probability. So that's going to be 8 out of 81, 8 out of 81, and 4 out of 81. So 8 and 8 is 16, 16 and 4 is 20. So that's going to be 20 out of 81. So this is what we get, and this is the answer in the simplest form. So then, now this is one way of doing it. Or else what we can do is, as you can see here, I have 9 rows and 10 columns, and in these 9 rows and 10 columns, I have written the same outcomes of spinner B at the top as well as at the bottom, like this. Now along the column and along the row, like this. Now getting a number that adds up to a 9 or more, it means that we're going to see which combinations make a total of 9 or more. So out of these, it cannot be 3 and 3. It cannot be 3 and 4. It cannot be 3 and 5. Then it cannot be 4 and 3. It cannot be 4 and 4 because it goes up to an 8. Then it can be 4 and 5 because that makes a 9. So it can be this one, these two, and these two, because that makes a total of 9 because it's a combination of 4 and 5. Next, getting a 5, when we consider the 5, it cannot be 5 and 3 because it goes up to 8, but it can be 5 and 4 because 5 and 4 is 9. This is also 9. These will be equal to a 9. At the same time, it can be 5 and 5 because these 4 will make a total of 5 and 5 means that is a 10, which is a number that is more than 9. That means the total number of outcomes that we have is this side 9, this side 9, which means 9 times 9 is 81. Out of 81, we need to check how many ticks or crosses I would mark here. So in this case, it's going to be 6 times 2, that's 12. And 12 and these 8 ticks that I have, that makes it 20. It will give us the same answer, 20 over 81. So we can also use a two-way table like this, which is in the form of a grid to do it. There's no problem with that. Or we can use this method to solve it. Now, when you do this using a grid, it makes a little more. It gives you a clear visual of what's really happening. We can visualize it properly, because there was one of the past paper question where you were asked another question based on the outcomes that we have here. So that's like a conditional probability. So from these, how many are found by adding two same numbers? In that case, if you have a grid, it's going to be much more easier, or even if you do not, you can still do the question. Let's move on to the next one that we have. Question D. This is the last part of this probability question. Let's see what we have here. Lucia keeps spinning spinner B until it lands on 4. Find an expression in terms of n for the probability that this happens on the nth spin. This is a very important question. So now for spinner B, landing on spinner B, we can easily calculate the probability. That is, for it to land on spinner B, the probability is going to be 4/9, because out of these 9 outcomes, getting a 4, we have 4 4s, which means the probability of it landing on a 4 is going to be 4/9. Then this happens on the last spin. Before that, she does this, she repeats, she spins this spinner several times, but it does not land on a 4. It lands on any other number that is not a 4. That means the probability of getting a number that is not a 4 will be 5/9. There are several instances that it does not land on a 4, so that's why we go with 5/9. And finally, it lands on 4/9. It lands on a 4, so the probability is going to be 4/9. We need to write this in terms of n, and on the nth term is when you end up getting 4/9 as the outcome, which means the terms before that, that is n minus 1, the terms before that, it does not land on a 4. So in that case, we would write this probability that we got for it to not land on a 4 as 5/9. We would write that as to the power n minus 1. Then we would multiply that answer that we get here with the probability that we have here. This is how it should be done. The next one is a question which is related to functions. Let's see how we can do this. Now, in this question, there are 4 different functions given to us. The first question is to find what f of 2 is. F of 2 means, now here you can clearly see that the 2 is given within the brackets here, right next to this f. That means this 2 is the input. That's what they're trying to say. If it's given as f of x is equal to a 2 means, this explains that this 2 is the output for the function that is given to us. That's the meaning. Now here, this 2 is the input, which means into this f of x function, which is f of x is equal to 2x minus 1, this x that we have here is replaced with this 2. That's the meaning of f of 2. That means this is the same as 2 times 2 minus 1, which is equal to a 3. The next one that we have is g of f of 2. That means first you need to find what f of 2 is. We already know what f of 2 is, which is 3. The output that you get for f of 2 is sent into g of x. That's the into g of x function. So that's like you have a function machine, you have another function machine. The first function machine is f of x function. The second function machine is g of x. First, you're going to send in 2 inside the first function machine. The output that you get here for the first function machine, which is this 3, is sent into the second function machine. And now they are asking what this final output is going to be. That's the meaning. So then, now here, f of 2, we already know that is 3. So that 3 is the value of x. That should be value of x that the x should be substituted with in the g of x function. So then the g of x function is 3x minus 2. This x that we have here should be replaced with the answer that we got here, which is 3. So this is going to be the same as 3 times 3 minus 2. So 3 times 3 is 9. 9 minus 2 is equal to a 7. So this is what we get as the answer. Then the next one that we have is to find the inverse function of g. So the function of g is equal to 3x minus 2. So this is y is equal to 3x minus 2. Then to find the inverse function, you first need to make x the subject. There are 2 steps to do. You make x the subject, and once when you make x the subject, you switch x and y around. So here this g of x is replaced with y here, because when I write g of x, it can confuse. That's why we write it as y. And then I need to now make x the subject. To do that, I need to bring the minus 2 to the other side. So that becomes y plus 2. This is equal to 3x. Then I need to bring the 3 to the other side. To bring the 3 to the other side, I need to divide both the sides by 3. That way I can get rid of this 3 here. So then y plus 2 over 3 is equal to this x. Now what I got to do is I need to switch this x and y around, which means I can write it as x plus 2 over 3 is equal to y. So I can write it this way, which means this is that inverse function they are asking for. So the inverse function of g is equal to x plus 2 over 3. In the next question that is given to us, we need to find what x is when h of x is equal to j of negative 2. So h of x function is given as 1 over x. So I'm going to write it as 1 over x is equal to j of negative 2 means into the j of x function, the x is replaced with negative 2. So j of x function is 5 to the power x, which means that here j of negative 2 means this x that we have here has to be replaced with negative 2. That's the meaning. Now I need to solve this to find what x is. When we consider this 5 to the power negative 2, now here there is no denominator, means there is always an invisible 1 in the denominator. Now here the index that we have for this 5 is negative. I'm trying to make it positive. To try to make it positive, I'm going to bring this 5 to the power negative 2 below the division bar, which means that becomes 5 to the power 2 in the denominator. So I can write it as 1 over x is equal to 1 over 5 to the power 2. This is what I get. So when I want to make the negative index into a positive, I just change the position. If it's in the numerator, I need to put it in the denominator. If the negative index is in the denominator, I just put it in the numerator. This is what I get. Now for me to find what x is, I'm going to cross multiply and see what x is. I need to make x the subject. X times 1 is equal to an x. Then I have 1 times 5 to the power 2. So 1 times 5 to the power 2 is 1 times 25. That is equal to 25, which means the value of x is equal to 25. So this is what I get. The next one is write f of x minus h of x as a single fraction. Now, h of x function is known to us as 1 over, f of x function is known to us as 2x minus 1. So I'm going to write that 2x minus 1 here. From this, I need to deduct, or I will put this like this and put the subtraction. I need to deduct the h of x function. So the h of x function is 1 over x. So this is what I have. I need to do this subtraction and write it as a single fraction. So now here for this 2x minus 1, there is no denominator, which means there is always an invisible 1. I need to make the denominators the same. To make the denominators the same, I'm going to times this by x. I need to times the numerator also by that same x. So when I do that, I end up getting x times 2x, which is 2x squared, x times minus 1, that is minus x. Then I have minus 1, I need to deduct this 1, and this entire thing is over x. So this is what I get. Now in this case, when we consider this 2x squared minus x minus 1, even if you factorize it, you won't be able to simplify it with the denominator. But there are instances when we are given a fraction like this, an algebraic fraction like this, if you are asked to simplify it, means you need to definitely factorize and then see if it can be divided with the denominator or not, if you can cross the numerator with the denominator or not. So in this case, we will always write it in the factorized form so that we know if we can simplify it or not. If we can simplify, we are going to simplify and write it. If we cannot simplify it, we are going to leave it the same way as it is. So when we have this 2x squared minus x minus 1, we have a coefficient in front of the term with the square, which is a 2. And to times this 2 with the number at the back, that becomes a negative 2. So I need to find the two numbers that make that negative 2 when multiplied. And when added together, I need to get the coefficient of the term in the middle, which is negative 1. So the two numbers are 1 and 2. So when we consider the 1 and the 2 has to be negative, whereas the 1 will be positive. So I can write this as 2x squared plus 1x minus 2x minus 1. I need to start pairing this. In this x, I can take out, I can factorize the x. So I have 2x plus 1. And in this, I can take the minus 1 out. So this gives us 2x plus 1 again. Then the terms inside the brackets are the same. So I'm going to write that once. And the terms outside the brackets, I'm going to put that together in another bracket. This is what I get, which means this numerator is going to be 2x plus 1 times x minus 1 over this x. I cannot simplify this further, so I'm going to leave it like this. But if the denominator was something like x minus 1 or 2x plus 1, definitely you can factorize it, you can simplify it. So that's the reason why it's always best to write it in the factored form. Let's move on to the next one that we have. Find the value of jj2. This means the meaning of this is, first you need to find, when you send in this 2 means we are going to send in 2 inside a function machine. The function machine is g of x function machine. The output that you get here is sent inside another function machine of the same kind. Then they are asking for the final output. Now here j of 2 function is, so j of x function is 5 to the power x. So j of x function is 5 to the power x, which means here the x is a 2. That means when x is a 2, this becomes 5 to the power 2. That is equal to 25. This 25 is the output that I get for the first function machine. It becomes the input of the second function machine, and we are asked for the final output. So then this 25 should be sent in this 5 to the power into this 5 to the power x again, where this x gets replaced with this 25, which becomes 5 to the power 25. Now I need to find what 5 to the power 25 is. So then let's see what we get. So 5 to the power 25 is what we need to find. That is equal to 2.98 times 10 to the power 17. So 2.98 times 10 to the power 17 is the answer for this question. The next one, the final one that we have here. Find x when the inverse function of x is equal to 4. This is actually very important because this is somewhat challenging, but this is a very good question that we have here. We need to find what x is when the inverse function is equal to a 4. Now here, the inverse function means if the inverse function is a fraction like this, or is an expression like this, or even if it's a fraction like this, in that case, to find the inverse function, like I mentioned, like we did in question B, to find the inverse function, we make x the subject, and then we switch x and y around. That is what we need to do. So we can do that, and after you find the function, after we find the inverse function, we can replace the value of x with whatever the number that is mentioned here. I mean, if it's given as the inverse function of a particular number, then that whatever that number that is mentioned should be replaced to find the answer. But here we cannot even find the inverse function for this, because the j that we have here is given to us as 5 to the power x, which is an exponential function. That means if I'm to write it here, so we have 5 to the power x here. This is going to be that j of x. Now this is something to do with the inverse function machine. That means if I'm to draw a small diagram to explain this to you, so we have this as the function. The function is going to be 5 to the power x. That is, when we send in an input, we get an output, right? The inverse function is from this end, when we send in, the output that we get is only given here as this 4. That is, for the inverse function, the output we get is equal to this 4. That's what they're trying to say. That means if I try to do it the other way around, it means that this 4 becomes the input for this 5 to the power x, and then they are asking what this output is. That means this 4 I need to replace wherever this x is, I need to replace this x with the 4 to find what that number is, which means it's going to be 5 to the power 4. That is equal to the answer here. So 5 to the power 4 is equal to 625. This is going to be the value of the output that they are asking for, which means simply if the input is 625 from for the inverse function, then we will get an output of 4. For the actual function, if we send in 4, we will get an output of 625. That's the meaning, which means in this case, the value of x is equal to 5 to the power 4, which is the same as 625. With that, we will be done with this function question that we have. Let's move on to the next one that we have. So this is the last part of the last part that we have. So this is about Venn diagrams. So then I really wanted to pick this Venn diagram question because we have expression. The Venn diagram is described in the form of a list like this, description like this. Let's see what it means. So here, the universal set means that they have mentioned here as the positive integers which are less than 13. All the positive integers that are less than 13 are from 1 all the way up to 13. So 1 all the way up to 12, not 13, because it doesn't say that it's less than or equal to. So then I'm going to write all the numbers up to 12, which are positive integers. So it goes as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then I have 12. I should not write the 13 because it's less than 13. Then the next one that we have is x is such that x is a number less than 9. So all the numbers less than 9 out of this I'm going to write. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So 9 should not be written because it's less than 9. Then the next one is x is even. So even numbers that we have here are 2, 4, 6, 8, 10, and then we have 12. The next one that we have is, so x is a multiple of 3. So it goes as 3, 6, 9. Then we have 12. So these are the multiples of 3 that we have. Now, the question that is given here is to complete the Venn diagram. So then, when completing the Venn diagram, all 3 circles are given. The region that goes in the middle is the overlapping region. The number that is common to all 3, all A, B, and C is the 6. This 6 is the number that goes in the middle because that is common to all 3 circles that we have here, or all 3 Venn diagrams. Then the next one that we have is we're gonna complete the rest. So if we check this A that we have, it goes as 1, 2, 3, 4, 5, 7, and 8. So in this, if we check A and C share 3 in common. So I can put that 3 here. So I'm done writing the 3. So I'll cross the 3 as well as the 6 as well because we are done writing the 6. Then the next one is when we consider A and B, that we have here, A and B share 2 in common. So they have 2. They have 4 in common. And then they also have 8 in common. So we are done writing the 2, 4, and the 8. Next, when we consider B and C, they both have 12 in common. So that's going to be here. I need to put that 12. And then the rest, we need to put in their respective circles. So when we consider circle C, we have 9 left. So that goes here. When we consider circle B, we are left with 10. That goes here. And when we consider circle A, we have 1, 5, and 7. I need to write it here. Now, out of the numbers that we have written the 1, 2 is written, 3 is written, 4, 5 written, then 6, 7 written. We have 8, 9, 10 is written, 12 is written, but we haven't written this 11. So that is the number that goes outside the circles. So this is how we should be completing the Venn diagram. Let's see what we have next. Once when the Venn diagram is complete, we are supposed to find n of A complement union B intersection C. So this n stands for the number of elements that belong to this region. That's the meaning. First, we need to identify what this region is. So then let's see what this region is. First, I'm going to explain how to shade this region. So we have B intersection C. The ones that is within the brackets, I need to solve first. And within the bracket, we have another bracket that is this B intersection C. I need to first identify the region. To do that, first we have B. So I'm going to shade in B completely. So this is the circle that I have for B. So I have shaded in B. Next, we have C because it says B intersection C. So this is the circle for C. I'm going to shade that completely. So this is the circle that represents circle C. B intersection C, the N in that represents that is the overlapping region. This overlapping region means the overlapping region of both the colors. So according to this, the overlapping region for both the colors, not both the circles in general, both the colors that I have shaded, will be the region where I have both pink and blue is going to be the region where I have marked 6 and 12. So that's going to be the answer for B intersection C. So then I'm going to shade that region now. So that is this region was the answer that I got. So this is what I got. This is what I get as the answer for B intersection C. So I'm done with that part. Now let's move on to the next part that we have. The next one that we have is, it clearly states that it's going to be A complement. A complement means that, or we read it as A prime. It means that everything but A. That's the meaning. That means this is the circle that we have for A. Apart from this circle, everything else has to be shaded. That's the meaning. That means if I'm to shade it, this is how it will be. This entire region should be shaded. This entire thing should be shaded. That's the meaning. So then in this question that is given to us, it states that A complement is the region that I have shaded in blue, and B intersection C is the region that I have shaded in orange in the middle here. For those two, it says it's union. Union explains that everything that is shaded. Everything that is shaded means it may have just one color, or it can have both the colors. In this case, it can be just blue, or blue and orange, or just orange. That's how we need to figure it out. Which means our final answer will be every portion except this portion that has this 3, 1, 5, 7, 2, 8, 4. Which means if I'm to shade in the final answer will look like this. So we will have this region. We will have every other region apart from this. So hold on. This is how it will look like. Okay, so this is what we would get as the answer. And in this case, the question is not asking us to just shade in. They're asking the number of elements that belong to that section. The number of elements that belong to that section means it's going to be this 6, 10, 12, 9, and for the region outside the circles, we have an 11. So we have 5 different numbers. So that's going to be equal to a 5. Number of elements that belong to that section is what we are supposed to find. So we just add the numbers that we have here and write it. Sometimes each of these numbers given to us for each of these sections represent the number of numbers in those sections. In that case, we would add 9, 12, 6, 11, and 10 together. We would add it that way. But here, this 9, 10, 11, 12, they are individual numbers. They are not number of numbers. So in that case, we individually count them. So we end up getting 5 as the answer. So we have 5 numbers here. So that's going to be the answer. So with that, we will be done with all the questions that we have here. Also, please make sure to watch the previous videos that I have uploaded related to this predicted question for May, June. Make sure you check both paper 2 video as well as paper 4. That's because there are certain questions like the compound interest. Then I did mention that there are some other topics as well, similar shapes. That is very important as well. So compound interest, similar shapes, I have some sequence questions there as well. Then when it comes to straight line graphs, I did mention that there is a very important question in that. So all those topics, all those questions, those important questions are explained in that video as well. So have a look at that as well. And then all the other topics that we sort of feel like we will get, and I have like selected questions from different past papers related to that, and I have covered most of the section. So I hope we get questions similar to this in the test as well. Let's hope for the best. And yeah, thank you for watching.